Good day, friends. Today I shall be talking on the topic calculating pi. Pi is an irrational number, rather, it's a transcendental number which is not any root of any algebraic equation with integer coefficients. So it is not possible to express pi in terms of fractions. Okay, so what we can do is at best is the approximations of pi. So calculating pi as fine as possible has been a challenge to humankind over the years. So today let us talk about that story. Let me start with the definition of pi. Take any circle and draw its diameter, then the length of the perimeter divided by the length of the diameter gives the constant pi. It's constant whatever circle you take, and this is known over ages since Egyptians, Babylonians. The concept this constant was known to humankind, and it is tried to humankind tried to approximate to find the decimal expansion of pi as correctly as possible, which goes today up to trillions of decimal digits. So starting with early history, there are mentions about Chinese mathematicians. Egyptologists told that Egyptians approximated pi as 22 by 7, which is 3.142857.04% high as over the true value. Then Babylonians knew about it and they used 25 by 8 as the approximation pi, which is 0.528% below the exact value. In Rhine papyrus, pi is approximated as 256 by 81, which is 3.16. In ancient India in 6th century before Christ, the fractional approximation used was 339 by 108. So there have been various fractional approximations of pi over the ages. Archimedes in 3rd century BC proved that pi lies between the two approximations 223 by 71 and 22 by 7, and this has been proved using a regular 96 gon. Chinese mathematicians use 96 gon and 192 gon to find the value 3 as 3.141866, which is close to the true value. Approximation of pi was used as 3927 by 1250. So these are all approximations, and actual value is unknown to us. It's never possible to express pi in an approximation using a decimal approximation. Early history about the Chinese mathematicians. Pi is approximated by 355 by 113. Aryabhatta of ancient India, 6th century BC, approximated pi as 62832 by 20,000, which is 3.1416. And in 15th century, Nilkantha Somayaji, Kerala School of Astronomy and Mathematics came out with the fact that pi is not expressible as a fraction. Madhava, the founder of Kerala School, used pi by 4 equal to tan inverse 1 to come up with the series 4 into pi by 4 equal to 1 minus 1/3 plus 1/5 minus 1/7 plus 1/9, etc. And this is known as Madhava-Leibniz series. And Madhava found a correction factor to the nth term, and in Middle Ages, Persian astronomer approximated pi as 3.1415926535897932, which is correct up to 16 decimal places. He used a regular polygon with 3 into 228 sides. These are huge calculations. Viet's formula came out in the second half of 16th century. Wallis product formula for pi came out in 1656. There are talks about English mathematician Shanks, who calculated pi up to 707 decimal places, but there are some errors in his calculations. Ramanujan in 1910 gave this formula to calculate pi, which has got a very fast convergence rate. In fact, only the first term gives you the value 3.14159.273. Mid-century onwards, computers came in, and Shank's calculations was corrected. 100,000 decimal places of pi are calculated by Daniel Shanks in the United States Naval Research Laboratory in 1961. Later, in following Ramanujan, several pi calculating formulas have come up, and this is one modification of Ramanujan's formula which is used even now. In 1989, IBM 3090, using following variation of Ramanujan's infinite series of pi, calculated the decimal expansion up to 1 billion decimal places were calculated in 1989 by IBM 3090 computer. And then 1999, 200 billion decimal places is calculated. In 2002, it goes to trillion, 1.24 trillion digits using 600 hours, which is same as 25 days. Computer hours is used to calculate the value of pi. So if we look at the number of decimal places calculated for pi, then the graph took a sharp jump in 1950 with the advent of computers. Recently, physics professor Anindya Saha and postdoctoral researcher Arnab Saha at the Indian Institute of Science has uncovered novel series representation of the rational number pi, simplifying calculations in the quantum physics. So they were trying to do their research in string theory, and as a side product, they developed a family of representations of pi which depends on the value lambda. Given any value of lambda, this gives the value of pi. And as lambda goes to infinity, this formula converges to Madhava's 600 years old formula for calculating pi. The talk is based on the Wikipedia page and the Scientific American article. I'll stop here. Thank you.